Here we come to A-Level Physics 1996 structure question 1. So we hit a ping pong ball, table tennis, horizontally with a speed v, and it goes over the net and hits the table, rebounds, and go to point E along a projectile motion. First of all, we are going to find the initial speed v. So because it's the initial speed, for the sake of clarity, I will just call it u maybe. So we are now going to find the value of u. And note that u is just a horizontal velocity. There is no vertical component, so uy is equal to 0 because it hits horizontally. Also, let us assume at the beginning time is equal to 0, and when it goes over the net at this point, the time is t. Why do I choose this point when it goes over the net? Why doesn't I choose point D? It's because, as you can see, do we know the horizontal between A and D? It is not given. So with the lack of information, we cannot calculate. However, if I choose this point, I would know the horizontal distance from A to the net is 1.35 meter. It is given as x. So it is more convenient for us to do the calculation with a known Sx. So throughout the motion, Sy is equal to 0.4, Sx is equal to 1.35. So first of all, let's find time t. How do we find time t? We can consider the vertical motion. Consider the vertical motion. Let's write down the equations of motion. Sy equals uyt plus half ayt squared. You ask yourself, what is the vertical displacement from this point to this point? Is it 0.4? No. Okay, Sy is not 0.4 because we are talking about this point and this point. The vertical displacement is 0.4 minus 0.15. Minus 0.15. So we have to put down 0.4 minus 0.15 equals uyt. Uy is 0, so don't need to care about this term. Half ay is 9.81. T squared. Solving this equation, we have t is equal to 0.2258 seconds. So secondly, we would like to find the value of u. So here we can consider the horizontal motion. We know that from this point to this point, the horizontal distance covered is 1.35 meter, and we have the time of flight. So we can write down Sx equals uxt. Put in the number. Sx is 1.35. Ux is what we want to calculate. T is 0.2258. So ux, which is equal to u, would be 5.98 meter per second. So this is the value for the initial velocity, 5.98. Part 2, we would like to calculate the speed just before it hits the table. That means at point D. At point D. So at point D, what happens is the horizontal, the speed will be along this direction. I call it v. So we can resolve it into vx and vy. Vx is the horizontal speed. It stays the same, so horizontal speed is 5.98 meter per second. And we can calculate vy using the equations of motion. Originally, at this point, there is no uy. And after it falls for 0.4 meter, then it comes to point D. So we can use Vy square equals Uy square plus 2as to calculate for the final velocity. Now we are consider the vertical motion. Let's put in the numbers. We know that Uy is 0, so no need to care about that. Vy square is equals to 2 times 9.81 times the displacement is 0.4. So 2 times 9.81 times 0.4, taking square root, Vy is equals to 2.80 meter per second. So now we have a horizontal Vx equals 5.98. We have a vertical Vy, which is equals to 2.80. So now we are going to combine the two components together and find V. V is given by 5.9x squared plus 2.80 squared it would be equals to 6.60 meter per second. This is the speed at D, 6.6 meter per second. Now then, when part 3 it is said that point E is 0.25 meter above the table. So point E is here, 0.25 meter above the table. So you are asked to draw the graph of vertical velocity Vy of the ball against time from C to E. Take downwards as positive. Now, so TC, TD, and TE are the time when the ball is at CDE respectively. Firstly, let's consider the ball traveling from C to D, and then it rebounds from D to E. We separate into two sections. From C to D, this section, the ball is undergoing gravitational acceleration. At first, Uy is equal to 0. At last, Vy is equal to 2.8. So it goes from 0 to 2.8. So we can draw the graph from 0 at C and 2.8 at D. So we have a line like this. And then what happens at point D? What happens at point D? Let's look at here. Before hitting the table, the ping pong ball is going down. But after it hits the table, it goes up. So in this rebounds, and after it rebounds, the speed will change from positive 2.8 to negative 2.8 in a very short period of time. So the line goes to here, and then after it is rebounds, the ping pong ball is undergoing gravitational acceleration again. So the slope should be the same as before. So you can measure the same slope and then draw a line until it reaches point E. So the graph will be looking like this. And by the way, point E is the highest point, as you can see. So the vertical velocity will be 0. So we can join the graph too.